And today's question is insert greatest common divisors in linked list. Given a head of the linked list head in which each node contains an integer value, between every pair of adjacent nodes, insert a new node with a value equal to the greatest common divisor of them. Return the linked list after insertion. The greatest common divisor between two numbers is the largest positive integers that evenly divides both. GCD. Yes. And here 18, 6, 10, 3. These are the nodes. And after inserting the greatest common divisor between 8 and 6, which is 6, and 6 and 10, which is 2, and 10 and 3, which is 1. Now this is our linked list. Yes, these this is our linked list, and we have to return this head of the linked list. So I got it. Let me explain. So the this is just the question. We have head of the linked list, and we have to find we have to insert the greatest common divisors GCD of the every nodes, GCD of GCD value of the nodes between the nodes. So here 8 and 6. So GCD of 8 and 6 is 6. So before insertion, uh, first we have to understand what is the current node and what is the like where we have to insert that GCD value between these two, right? So here we already have head. So we have to return this head of the linked list after insertion. So that's why consider this is the current node and this is the next node. Okay. So this is the next node, and we have to create a GCD node between 8 and 6, which is a 6. Now I created a GCD node which is 6, and first we have to connect these 8 and 6. We have to store this 6 address in this 8 node, so which is nothing but current of next is equal to this GCD node. Here this represents the GCD node. Okay. And we have to store the sixth address in GCD node. So GCD of next is equal to this next node. And after insertion, we have to move our current node and the next node. So then so this becomes the current node, and this becomes the next node. So this becomes the current node, and this becomes the next node. After that, find the GCD node between them two and 6 and 10, which is 2. So what happens? Okay. So this represents the two GC, which is GCD now, and now current of next is equal to this GCD node, and GCD of next is equal to this current node, right? So when current of next is equal to this GCD node, actually before storing the GCD node into the current of next, the next node is stored in the current of next value. So when current of next is equal to GCD node, this address is uh, like this address is shifted to this GCD node. Here also same. This address is, I mean, sixth node. I mean, next node address is actually not stored in current of next value. GCD address is actually stored in the current of next value. So similarly, here 10, between 10 and 3 nodes. So after inserting the GCD node between 6 and 10, we have to shift our node values, right? So next is equal to next of next, and current is equal to next. So current next, and between them the GCD node is one. So on, so current of next is equal to GCD, and GCD of next is equal to next. And when this next is equal to next of next, when next is equal to null, so actually there is no value, right? So now we have to return our return head value. So this one. So that's it. Let's see the code. And we have one thing. In order to find the GCD value, we have traditionally we have to write a for loop. Sorry, while loop. So while loop we have to pass while of value 1 and value 2. So between them we have to perform the division operation. So we have to write a recursive function value for finding this GCD. But in C++ we have an inbuilt function. In C++ we have an inbuilt function GCD which takes two values and returns the GCD value of that. Let's see the code. Yeah. Here first we check whether head is null or head of next is null. We just have to return that head because there is no need to add GCD value when we have single head or when we don't have head. So and then if there is a linked list, so take the head is equal to the current node and current of next is equal to next node, right? So head is equal to the current node and head of current of next is equal to the current of next is equal to the next node. So this is the next node. That's what we are taking. And then while next node is present, so find the GCD value and create a node for the to store GCD value. So this is an inbuilt function which takes two values and return the GCD value that is stored in the new value G. So this G represents the GCD node. And after that, what we are storing the current of next is equal to G and G of next is equal to next node. So current of next is equal to G node and G of next is equal to next node. And then we have to change the current, move the current and the next node position. So current is equal to next and next is equal to next of next. So this value has to be run until next node have a value. If next node don't have any value, so it returns while loop stops and we return our head.